Mobile air pollution sources, which include motor vehicles and trucks, are the largest contributors to air pollution in the USA. If you consider the expanding economies in developing countries such as India and China and a growing demand for personal vehicles, you can forecast this is a continuing problem that will have to be dealt with. Although cars and trucks have become more fuel efficient since the implementation of the Clean Air Act, there are now more vehicles on the road and typically more miles driven, which means that fuel efficiency has to increase just to keep up with the growing demand of these vehicles. The primary pollutants from mobile sources are carbon monoxide, carbon dioxide, oxides of nitrogen, and hydrocarbons. There is a fairly straight linear relationship between the amount of fuel consumed and the emissions created. The more fuel consumed, the greater the pollutants. Hence, increased fuel efficiency is an effective method to reduce emissions. There are many ways to optimize engine performance, including modifying the fuel to air ratio, using the spherical shape for the combustion chamber, altering the combustion chamber temperature to allow it to reach high temperatures quickly where the fuel is more efficiently burned, and recirculation of the fuel exhaust. Emissions are also treated by the use of catalytic converters that reduce oxides of nitrogen, carbon monoxide, and hydrocarbons. The removal of lead from gasoline is one of the greatest pollution reduction success stories. Lead was added to fuel to enhance engine performance and reduce so-called engine knocking. However, exposure to lead can result in damage to the brain, cause learning disabilities, and hypertension. Lead was incompatible with the catalytic converter and had to be phased out beginning in the 1975 model year vehicles. The amount of lead dropped from around 4 grams per gallon to less than 1/20th grams today. There were similar declines in the amount of lead measured in the environment and humans. Most fuel now contains up to 10% ethanol. Although ethanol burns cleaner than standard gasoline, it delivers less energy. Some vehicles are equipped to burn up to 85% ethanol. There are many debates regarding the merits of ethanol-enhanced gasoline, as most of the ethanol is derived from corn. However, as a domestic source of fuel, it provides the USA with more control over its energy's future. An effective method to reduce emissions is the use of fuel-efficient cars. The Obama administration put rules into effect that will increase the average fuel efficiency of automobiles to 54.5 miles per gallon by 2025. Hybrid vehicles will likely play a major role in achieving these new standards. Hybrid vehicles use standard internal combustion engine supplemented by a battery. The battery is recharged when braking. Electric vehicles do not use gasoline but rely solely on electrical charges obtained by plugging into an electrical outlet. The emissions produced by an electric car are those emitted by the power plant that supplies the power to where the vehicle is being charged. Ironically, a coal-burning power plant could charge an electric car. Stationary sources include power plants, manufacturing operations, painting, and other coating, and even some bakeries. Typically, these pollutants are released through an exhaust stack, although there are also fugitive emissions such as coating operations that can take place in an outdoor yard. It had been common practice to use tall stacks to release the pollutants into a typically more turbulent part of the atmosphere, where there was more air movement, dispersing the pollutants to wherever downwind happened to be. This does not really treat the air pollutants, but rather only dilutes. Airflow through exhaust stacks can be treated to remove particulates, sulfur compounds, and other materials. The treatment materials must subsequently be managed as a controlled waste, which may require further treatment before it can be properly disposed.